Okay, here we are, 6-5, day 1. We will be quizzing after this section, but again, we are going to spend 2 days here. Okay, this is all about doing the derivative when the x is up in the exponent. You have not had a way to do that all year other than to use your function integrate on your calculator. So when x is in the exponent, we're going to be hitting with a log to knock it down and then doing derivative after that. So hit it with a log. And it's going to be the natural log we're going to use, ln. Okay, it's a 5-step process. Your first step, when you see the x up in the exponent, the first thing you want to do is take the natural log on both sides. So take the natural log of both sides of your equation. Then use your log properties to bring the variable down out of the exponent. And now you're going to be at your derivative rules. But because you're not going to have a y equals equation anymore, it's going to be implicitly differentiate both sides. So it's implicit differentiation. Implicitly differentiate okay, just means take the derivative on both sides, and when you take the derivative of a y term, remember you just multiply by a y prime. So now we're into that process of solving implicitly. So after you have your derivative, you solve for y prime. And then at the end, you're still going to have to substitute for y. Okay, so it's a 5-step process. I'll take you through several examples. Here we go. If I had y equals 5 to the x, and I want to do derivative, okay, as soon as you see the x up in the exponent, think, oh, I don't have a rule for that. I've got to get it down out of the exponent. Hit it with a log on both sides. So the first step, do natural log on both sides. Then you can use that property of logs that lets you bring the exponent down in front of the log word as a multiplier. So this side's going to stay natural log of y. Now I can bring the exponent down, and it's x times the natural log of 5. Okay, now I'm ready to do derivative. Now it's in a form where the x is down. We're ready to go. Left-hand side, not a problem. It's a natural log. Your rule for derivatives of natural logs, I had it right here. Derivative of natural log, 1 over u times the derivative of the u. So it's 1 over y. The derivative of y is a 1, and then times y prime, because that's where we do it when it's not a y equals equation. It's called implicit. Okay, big stumbling block for people right here. They see this natural log of 5 as a variable for some reason. This is a constant. The natural log of 5, let me take a look, calculator. Natural log of 5 is like 1.6 approximately. So what I actually have here, think of it as 1.6x. This is your natural log of 5. That's the value of it. So this is a constant. What happens with a constant multiplied by an x? The constant just carries along. What is the derivative of x? Derivative of x is a 1. And my constant carries along. Right here, if I had 1.6x and asked you to do the derivative, the x goes down to 1, you keep your multiplier. 1.6 is the derivative. It's exactly what I've got here. I didn't need to put the 1. I just want to show you. Take baby steps through here. But this is a constant. Okay, so I've done derivative on both sides. Now I just have to solve for y prime. So here's y prime. I need to get rid of this y. Well, to get rid of it, this side is being divided by y. I'm going to multiply by y on both sides. So it's just algebra now. So if I times by y, these cancel. I'm left with y prime equals the natural log of 5 times y. Okay, I solve for y prime. Now I want a derivative in terms of x, not in terms of y. Well, I know what y equals. I started out with y equals 5 to the x. So this is that step 5 where it says substitute for y. You want your derivative back in terms of x. So the derivative would equal the natural log of 5 times 5 to the x. Or the order might be switched, 5 to the x times natural log of 5. The order doesn't matter there. Okay. This is usually the biggest stumbling block where people can't see that as a constant and the constant just carries along as a multiplier. Pretend it's not even there. Take the derivative of x, carry that along, and you're good. Let's do several more of these until you get comfortable. I think I can fit this in over here. Number 2. I've got h of x equals x times 4 to the x squared. Okay, right away I see this x squared up in the exponent. That tells me I've got to do this new way. I've got to hit with a log on both sides. I don't like this notation for because I have to write it so many times. So if the book starts out with this, I'm going to recommend you just change it to a y. You'll see in the answer book he does not do that, but I like to just because that's obnoxious and the y is less obnoxious. Okay, so I just rewrote it with a y equals. Okay, when they see the x in the exponent, hit it with the log on both sides. So I've got the natural log of y equals the natural log of x times 4 to the x squared. Okay. Biggest mistake people want to make here is they want to pull this x squared out in front right now. I can't do that because the x squared is only on the 4. It's not on this x, so I can't bring it past it. So what I need to do is use my log properties and break this apart. So I'm not ready for derivative yet, so that's going to stay. Here, when I have the log of a product, the log of a product breaks apart into the log of the two logs added together. So this becomes the natural log of x plus the natural log of 4 to the x squared. Now it's okay to bring the x squared down in front of just this term here. See the difference? I could not do it here because the x squared is not a part of the exponent on the x. So one more move, then we're ready for derivative. Bring the x squared down, and I've got a natural log of 4. All right, now I'm ready for derivative. Here, 1 over y times the y prime, 1 over x. Derivative of x is 1. Here, what do I have going on here? Natural log of 4 is a constant. It's like 1.6 or something. You see, natural log of 4, 1.4. Okay, don't worry about that. That just carries along. Do the derivative of the x squared. Derivative of x squared is 2x times natural log of 4. So that's 3 things multiplied there. 2 times x times natural log of 4. Can't multiply the 2 and the 4. That's not legal. So that derivative is done there. Now I'm at the point where I need to solve for y prime. I need to get rid of this y. This is 1 divided by y times y prime. So for me to cancel out that y down there, I'm going to multiply both sides by y. This side has 2 terms, so I need a set of parentheses. times by y. So y prime equals 1 over x plus 2x natural log of 4. And now I'm going to substitute for y because I want all x's in my derivative. I don't want x's and y's. And remember, y is equal to x times 4 to the x squared. There it is, done. So lots of algebra things going on, little things you're going to want to make mistakes on that I'll try to point out and avoid. Try another. Y equals x raised to the cosine x. Don't be afraid of the trig function. First thing you recognize in this problem is not this x, but this x up in the exponent. I have to hit it with a log before I can get started. So it's natural log on both sides. If you want to bring that down right away on this second line, go ahead. I'm just not going to skip any steps. So now I can use my exponent rule and bring that down as a multiplier. So it's cosine x times natural log of x. Now I'm ready for derivative. I no longer have an x up in the exponent. Left-hand side, not a problem. 1 over y times y prime. Here, what am I going to do on this side? Hopefully at this point you can recognize this as an x term times another x term. That tells you product rule. This is my u, this is my v. So we're going to follow a product rule here because I've got two x terms multiplied. So I start with the derivative of cosine as negative sine times by the v plus, keep the first term, times by the derivative of the second term. Derivative of natural log of x is 1 over x times 1. And then now I just solve for y prime. I've got to multiply by y on both sides. So timesing by y cancels. I've got a couple baskets here. The whole side has to get multiplied by y. So this, nothing's going to simplify in here. I can kind of combine this into a single fraction, but that's about it. So negative sine x, natural log of x, plus cosine x over x. Those two baskets times by the y, and I don't want a y, I want to switch it back. Y was, or y is, x raised to the cosine x. Done. Let's see, that one looks exactly the same. I'm not going to do another one of those. Okay, this is going to be our last one. This is number 22. And it's asking us to do the derivative two different ways. Do a derivative two ways and show that they're the same. The first way is just to jump right into the derivative. First line is, and then on the second way, we're going to use a log property first to change it and then do derivative. So first, do the derivative right off the bat. Deriv is your first step. So for this one, I've got y equals the natural log of, I'm going to go square bracket 4